Back to my channel, and in this video we are going to learn about deletion in red-black trees. So order of log n, this represents the time complexity of the deletion in red-black tree. This is the time complexity. Now the steps to follow to delete in red-black tree is, it is same as you do in BST, like if there is a leaf node. Suppose I'm having a tree like A, B, C, D, E, F and G. Suppose if I have to delete a leaf node, then we used to delete it directly if it is a leaf node. And if we have to delete a single child element like C, then we replace C with F and we remove this node. And after that, if we have to remove A from here, then we take in order predecessor or in order successor. From in order predecessor, we take the maximum element and replace it with the root node. And from in order successor, we take the minimum element and replace it with the root node. Now after deletion, what is left over? We need to handle the colors, because in normal one we used to not have the colors, but here there are two different types of colors, red and black. So that's the reason we also need to handle the colors. Now suppose let me take two variables and explain how we actually recolor any of the node where we have deleted. So suppose V be the node which we are deleting and U be the child which is replacing V. Okay, so V is nothing but this and U is its child. This is child and this is the parent node. So if you are deleting a node called P, then you will replace it with C, right? So that is represented by U. Okay. Suppose now there is a leaf node and you have to delete this. So the children of the U are these null nodes. I have already said in the last video. So these are also black in color, both of them. Okay. So let's see the two possible cases. Since it is red and black, so what are the possible cases for the parent and child? It will be either red or black, or else both would be black. Okay, red and red is not possible because this violates the red black tree property. So that's the reason the possible two cases are red black or black and black. Okay. Now let us come to the case 1. Either U or V is red. That means suppose you are taking V over here and U over here. He is telling that either it can be red black or it can be black and red. That means any of the one is red or black. Any of the one is red. So in that case, you simply have to color U with the black. See, if you delete V and you will replace it with U, then you simply have to take the color of U as black. So that's the rule. Now the second case is where U and V both are black. That means you are having two variables and both of them are black. And in this case, you will get a double black. Suppose you are deleting V from here. Then this black also goes to black and the color of U becomes double black. It is represented like this. Double black. Okay. So to fix this double black, we need to, let me explain it again through three different variables. U is the double black which you have formed and S is its sibling. That means sibling is nothing but its brother or sister, and parent is nothing but, see, this is sibling, this is U and its parent is this. Okay. So now we need to follow the cases to solve the following double black. Now there is a small rule for double black, that is, if the double black is for root node, I mean if it is for this A, B, C. Now since A is a root node and it is having double black, so you can normally remove the double black and make it into A black. That's it. This is the one rule you need to follow. So until you don't go to the root node, you have to not stop this following processes. Okay, because only then you can remove the double black. Now let's see the first case that says the sibling is black and one child is red. That means, see, now this is the parent, this is sibling, this is the U. Okay, its sibling is black and it is having one child as red. So it can be either left child or right child. So this is the sibling and its child is in red color. So this is what it's telling. If this is the condition of double black, then what you need to do, you need to perform the rotations and also you need to recolor them. Okay. So this there are four types of rotation. One is LL, LR, RR and RL. LL is nothing but you simply perform right rotation, and when it is LR, you simply convert it into LL. I mean you rotate the parent part to the left side, and once it is in the form of LL, you simply have to perform right rotation. If the case is RR, then you need to do left rotation, and if it is RL, then you need to first convert it into RR, I mean of parent, and then you need to do the left rotation of the following. Okay, so after rotation, to recolor them, so these are the rules to recolor them, that is, new parent will get black color and the child also becomes black and old parent also becomes black, and the double black gets removed. Let me show this to you in an example which would give you a better clarity of problems. Okay. Here the new parent and old parent, it is of U. For U, the new parent will become black and the old parent also will become black. Okay. In this case, the child is nothing but the red child of the sibling which we have taken. So it will also become black in color and the double black gets removed. Now coming to the case 2, it says sibling is black and both its children are also black. What it means is, this is parent, this is the child, this is the sibling, and both its children are also black in color. This is what it's telling. In this case, we just simply have to recolor. Color sibling red. So this sibling would turn from black to red, and we need to move double black to parent. Now from child this would go to parent. Okay, and if the parent was red, then simply this would get turned to black. But if the parent is already black, then this black also comes and attaches to parent. So that time the parent would become double black, and then you need to follow the same process. Like you need to check the sibling of this parent, and then again you need to pass the double black to its parent. So now this would become grandparent of the child. Now if this is the root node, then here you can directly remove the double black. I'll explain it to you clearly in an example. Okay. And then the third case says the sibling is red in color. That means you are having parent, child and a sibling. If the sibling is red in color, then you need to simply follow these instructions. I mean, you need to convert to black sibling case. So for that you need to rotate parents towards U. So this is our U. Okay. So you need to rotate the parent towards U. That means you simply have to perform right rotation. Okay. After that you need to swap colors of sibling and parent. So this is the sibling. You will change it to black, and parent color, if it was black then it will change to red. If it was red it will change to black. And then now the new sibling becomes black. Then you need to, now the new sibling of this becomes black, and then you need to apply case A or B where the siblings are black in color. Okay. After performing this rotation, actually then S would come at the top, and if there is a child of S, let me represent it with SR, then P would come here and SR would come here. After recoloring them according to the swapping rule, then you can remove this U double black from here directly. So this is how you end the process. Now let me show it with an example. Here they have given us a red black tree and we need to perform deletion according to the above rules. So let's see how we will do it. So the first element to delete is 5. Since it is a leaf node, you can directly delete it, and since it is a red, so there is no problem in deleting. So you can directly delete the leaf node. So I'll draw it again. Now the next element to delete is 10. So it is having one single child. It is which case? It is the first case, which shows that either U or V is red. So this is the following case. What you do, you simply color U with black. That means whichever you are replacing it, you will take the color of it as black. So that means it turns to 20. In place of 10, you will replace it with its child. So it's 15 and 30 over here. Next comes 25. Next is 40. Okay. So you simply have replaced the color also. If it is either red or black, you will make it black at the end after replacing. Okay. Now the next element to delete is 15. So 15 is a leaf node and it is having two black children and they are nil. So since it is having both black child, so now it will and this is also a black. So black and black, it would become double black. Okay. So now this would turn to 20. 15 would get removed and this will replace by a nil node with double black. It is represented by DB. And 30 over here, and it is having two red children in the right side. Now we need to check the case. Double black is there. Its sibling is black and it is having two red children. Double black, its sibling is black with two children. So sibling is black. So here we need to use the A case, because this says sibling is black and one child is red. So we are having two child as red. So there is no problem. We can take either one child or we can take two. Okay. It is like one of the child is red. One of the child. So we need to use rotation and also recoloring. So let's see what it's. So since it is an, you can take either RR or you can take either RL. So I'll take RR. So for RR we simply do the left rotation where at the grandparent. If this is the child and this is the parent, then this would be its grandparent. At its grandparent, you simply have to perform left rotation. Okay. So now 30 would become the root node, 20 at its left, and nil double black. At right of 30 we are having 25 and 40, and left of 30 we are having 25, so this would get replaced over here. 25 with red color. Now before coloring the rest of the others, we need to see the rules again of recoloring. Okay, recoloring says that new parent would be black, old parent black, and the child which we have selected also becomes black. So that's the reason I am not going to color 40 with black, 40 with red. So this child would get converted to black, and the new parent also would become black. The old parent also would become black. After completing this, we can directly remove the double black from here. That's what it says. So now I am going to remove this double black from here. Now the next element to delete is 25. So let's search it. It is left of 30 and right of 20. Since it is red, so you can directly delete it, and it is a leaf node. So you can directly remove the element. The next element after 25 is 30. So 30 is a root node now. So to remove the root node, we need to either replace it with either of its child, in order predecessor or in order successor. But in order predecessor and successor, we are having only one element. So we will just replace it with that element only, either 20 or either 40. So suppose I am replacing it with in order successor, that is 40. Then what would happen? Since both of them are black, this would give a condition of double black. So this would turn out to be 40 with double black, and then left of 40 is 20 with black color. Okay. So now to remove this double black, we can remove it directly, because what I said one thing, that if double black is in the root node, then we can directly delete this double black and it would become a normal black. So now this would turn out to be 40 and 20. Okay. Now the next element to delete is 40. So what would happen? Now deleting 40, it would get replaced with its child, and since both of them are black, so what would form? A double black would form. This is a double black. Now since this is a root case, so we can directly remove the double black and it would give us a single black. Okay. So that's it. I'll again replay the condition so that you will get a clarity. If a child is in red color and it's in leaf, so you can directly delete it. Okay. If it has one child, then you need to replace it. If it has two children, you need to take in order predecessor or in order successor. Now if either of the U and V, like U is the child which is replacing our deleting node. So if either of them are red, then you can simply recolor it with black. If both of them are black, then there's a problem, because it is, why there's a problem? Because when you are deleting black node, you are affecting the black height property of red black tree. So since this is getting affected, you need to refix this. This is the main reason for refixing of the color. Okay. So when you have both black, then you'll get a double black condition. To remove the following double black, what you do? You check its sibling is black and either of its child is red. Like any one of the child you can consider, and you can perform the rotations for that sibling and that child. After performing that, you need to recolor using these conditions after rotation. Okay, this is the child which you will select. Suppose in the last case we have seen that there were two red childs. So whichever red child you are selecting, that you need to color with black. Okay. Now the case B says sibling is black and both children are also black. So what you need to do? You simply have to recolor according to the following rules. And another thing I have said that if it is a double black at the root node, you can directly remove it and turn it to black. That's it. And the third case says the sibling is red in color. So what you do? You first convert to black sibling case. For converting like that, you need to first rotate it towards the U. You need to rotate parent towards the U. Suppose you are having parent over here and here is your U element and here is something your sibling. So this parent has to get rotated to the right side if the U is on right side. Suppose your U is on left side and your sibling is on right side. Then this time you need to rotate your parent towards left side. So this is the case. Okay. After that you need to swap the colors of sibling and parent. The new sibling becomes black in color. Then after the new sibling becoming black in color, you need to again apply the following cases, that is either A or B, because the double black wouldn't be gone. Now there is a small example for you. Solve this example according to all the rules. First try to understand the rules accordingly and then solve this problem. And this would give you a whole clarity about the concept. Hope this video was helpful. If it was, then don't forget to like, share and comment your opinions below, and don't forget to subscribe to my channel if you are new, and see you in the next video. Until then, bye bye.